Okay, good morning.
Good morning.
My name is Gary Matsuoka, and this is Brett Laguna Hills Nursery in Santa Ana. And today's topic or class is on um, things that you do in your garden that make the plants do the best. Watering, the right way to water, the right way to fertilize, mulching, and then crop rotation. So the last few weeks we've been doing a lot with getting the perfect soil on your plants. That's the most important thing, is getting the right dirt. And what we have been saying is that sandy loam is the ideal soil to grow plants. And the problem with our industry as a whole is that everybody's promoting some kind of organic material as a growing medium. And it's about the worst thing we can think of that you can use. You know that soil is sand, salt, and clay, which is pretty much quartz, which is a ground up rock. Granite, you grind up granite, you get good soil. You grind a plant, you get, or a plant, it's like a hell world. It's full of fungi and bacteria ready to rot this plant and turn it back into nutrients instead of growing in it. Plants won't grow in here. This is a nutrient source for plants, but it's not where plants grow. And unfortunately, what we would call the organic movement that's been occurring since the 80s. They've been telling the nurseries, if you want to be an organic nursery, you got to grow plants and dead plants.
Hmm.
That's the whole theme. They say, well, if you use um, something else, you're not being organic because you're not recycling. So they're trying to make the nurseries grow their good plants in dead plants. And that's like the worst place you can think of. You make your house, you don't make it out of dead people. That's like the worst thing you could ever do, is make your home out of dead people. The nutrients, the dead plants belong on the surface of the ground, and that's not where the roots are. The roots are in this. This is on top, and that's where the mushrooms and bacteria, the earthworms, the pill bugs, all the other organisms that do the recycling, that's where they live. So that's the main thing. So first week we talked about this. The second week we talked about how to fix this. Now we're going to talk about everything else. Um, Now, one thing to know about plants that we mentioned, the first one, is that most of the plants, the functional roots are within the top foot of soil. They don't go deep. Um, Maybe if you have really, really sandy soil, maybe 2 foot. But under normal soil conditions around here, about 1 foot, especially, there's traffic over the soil. You walk on it, cars drive over it, then you're talking the top foot or even a little bit less than that. Uh, Even trees that are 40, 50 foot high, you notice when they blow over, they just lift the surface of the soil when they're blowing over because that's how deep their roots are. And that's natural. I mean, they say in a forest, there's not much difference. Uh, the, in a forest, they said the average, well, the first foot of soil has got 60% of the root system. And then there's very few roots below 2 feet. The only time you can see roots go deeper is if there's a way to get air down deeper in the ground, because the roots actually have to breathe oxygen. So they said in a steep mountain canyon filled with just loose rock, you'll find tree roots 25 foot down because the air can get down that deep. But if it's normal soil, a foot, foot and a half is about it. So that's the area where we got to keep it water. Now, the water, the main thing about irrigation, if you're talking about production plants are things you want them to do something, not just sit there and have leaves, but to actually bloom or fruit, something like that. Vegetables, fruit trees, roses. You want to keep your entire root system moist. You won't want it to go dry. Now, if you've got just a hedge or a ornamental tree, yeah, you can let it go dry and plants start wilting and water again. Most of the landscape plants can handle that, but a production plant, you let it go dry, a lot of bad things happen. They'll abort their crop. You'll get cracks and the food will split or crack. So you want to maintain soil moisture throughout that. Now, how do you tell that it's moist enough? So 20 years ago, an agricultural agent told me that before farmers had computers, they walked around with a piece of rebar. Didn't have to be quite this thick, but something about 4 foot, 5 foot long. And they would, wherever they were irrigating, they would push this in the ground as hard as they could by hand. Generally, if soil is moist enough for plants to get, for the roots to get moisture out of it, you can push something through it. Just like, modeling clay in classrooms. If it's moist, you can push anything through that clay. If it's dry, you can't push anything through it. The same thing happens with all soils. If they're dry, you really can't push anything through them any depth at all. So they would say if the farmer can push this down, on most farms, they have better soil than we do. They've got this real sandy stuff. So they want to be able to push this in the ground about 18 inches. Now, most homes, if you can push it in 10 inches, you're doing pretty well, your moisture. So that's how you tell how moist your soil is. The moisture meters that are made that are electronic, they will tell you it's wet until the plant's bone dry and dead. They're too sensitive to moisture, so we don't recommend those. This is stick. The net metal could be a wood dowel, could be a fiberglass rod, but anything about finger thickness, you can push it in. It could be thinner than that if it's strong. If you can push it in. Now, this year, I would imagine we're up for over 20 inches of rain. You can probably push this in a couple feet in most yards, unless you hit a rock or you hit a root of a tree. You should be able to push it in about 2 feet. I remember 1998, 35 inches of rain that year. I can push this thing in about that deep in my clay soil. I was amazed. I had never been able to even dig that soil before that, and suddenly you go out there after the rainy season, push it in 3 foot deep. Farmers nowadays use tensiometers, which are tools that they install in the orchard permanently or the farm permanently to tell the moisture level. Now the thing about homes is that we can't do what farmers do. So farmers know, they've got a monoculture. They'll have an orchard of trees. Every tree has the same exposure, the same soil. They will know how much water that tree is using and how much they need to water. Well, in your backyard, you got a house there, you got walls there, everything's affecting the airflow, the moisture, the sunlight. If your neighbor has 80-foot eucalyptus trees, you're in big trouble because that tree is sucking 100 gallons of water a day in the summer. So it's hard to tell how much water the plant using. All you can do is check it to make sure you got the moisture in there. I remember in my last house I lived at, the Greenbelt Association planted these pine trees that within 10 years they were like 80 foot tall. And I couldn't keep anything alive on that side of my yard because they didn't water enough for those big pine trees. And if I wanted to grow stuff on that side of my yard, I would have to water the pine trees first before I can get my plants going. Oh, is this just not fair when you have those big trees around? Now this year, the ground's loaded with water. In Oregon, it pretty much always is. At Oregon, they get a lot more rain than we do. And they said that their ground is underneath their farms has always got 5 foot of water. And that's why their plants do better there. They claim you can't grow apples in California because their soil's too dry. Up in Oregon, they said they've got 5 foot of groundwater right underneath the tree that the trees can absorb. So it makes them look a lot better to have that. But anyway, watering wise, now we know lawns need about as much water as any plant does. So any plant you grow is going to use the same amount of water as a lawn or less. So lawns have been studied quite extensively in Orange County. There's a facility right in Irvine where they do the evapotranspiration. They tell you how much water lawns need and your sprinkler running time and all that. So what they found out is that well, sprinklers average sprinkler applies about, now there's a lot of different kinds of sprinkler methods, but normal run-of-the-mill sprinklers put on about, oh, quarter-inch of water in about 5 minutes. Somewhere between 1/8 and 1/4 inch of water in 5 minutes. And a quarter-inch of water is about the maximum water that the ground will absorb per hour. Some areas it's only 1/8 of an inch per hour. So 1/8 of an inch to 1/4 inch of water applied on the surface per hour. So the water district tells you, you should only run your sprinklers 4 or 5 minutes at a shot because everything else is runoff. So if you don't have perfectly flat ground, if you got slight mounds on your yard, you run it more than 5 minutes, then you start getting more water in the low spots than you do on the high spots, and that's going to mess you up in the long run. So they say 1/4 inch, 5 minutes per hour. You can water, and the next hour you can water again, 5 more minutes and get that water to absorb, but don't run it for more than 5 minutes. And in my neighborhood, you can see sprinklers go on for, like an hour, and they're only getting 5 minutes worth. And so the rest of it's going down, hopefully Orange County can recapture that water that's going down the storm drain, but they're wasting their water if they water more than about 5 minutes. Now, they do say in the middle of winter, say January, lawn only needs 4 minutes per week. With the average January temperature, 69 degrees, daytime high. This year we're running way below that. We're running more than 5 degrees below normal. But 4 minutes, so one watering per week on a lawn in the winter without rain is sufficient. But in July, 44 minutes. That means if you want to keep your lawn looking good, you've got to water 11 times, which means that's more than once a day. So, you say once at 6 o'clock in the morning, once at 7 o'clock in the morning. Now, you don't have to do it spread out too evenly, but fairly evenly. So you can do 3 times a day, 3 days of the week, something like that. 4 days of the week to get in 44 minutes. That's where the average Orange County temperature was around 85, 86 degrees on the daytime in July. If it's around 100, you got to water 3 times every day. Keep that lawn happy. Now, the nice thing about grass is when they did studies on it in the 80s, they found out that all the major lawn grasses being sold can withstand 3 months of drought. So, so essentially in summer, you can just turn off your water, let your lawn turn brown. It's still alive. It just goes to sleep. So grasses in the world, around the world, are found in areas that have a dry season. So they just go to sleep, turn brown. Actually, the dirt can, your lawn can look like dirt, and the grass is still there. It's just gone dormant. And then you get the moisture back down a foot, and here it comes back. 2 weeks later, after you return the water, it'll just come right back. So they've done that with every single major lawn grass. So we found out in our yards, when we found out how deep the water's got to be, we started using this to see what the grass looks like at different stages. So at a foot or more of water, the grass looks perfect. At about 8 inches, you start getting those white tips on your blades. At about 6 inches, it just wilts down. It starts looking pretty grayish green. And at 4 inches, you have 4 inches of mud, your grass is dormant. It's just sleep. So we have some people bring in a sample of their lawn and said, "Look how muddy this is, and my grass looks dead." But they only brought in this much. So grass needs the soil wet, good foot deep. Be happy. They say it's St. Augustine a foot and a half. So, and all grasses use water quite rapidly. There are a few grasses we have now that use maybe 2/3 to half the water that say bluegrass or a marathon fescue grass would use. But all grass, again, you can let them go dry. It depends on what your homeowner association says in summer. If they want you to have a green yard, you're stock. Of course, you can spray paint it green, but that's one way to save water, which I don't know why the water district doesn't recommend that. Maybe they have people that will sue them because their lawn died. But anyway, so most plants will use less water than a lawn does. Um, now drip system initially is more efficient than sprinklers are, but drip systems are much more delicate. So most farms use drip, but on most row crops, they replace they drip tape, which is a flat tape they put alongside their crop that holds every foot and it drips out. But they replace those with every crop, every season. They replace it because they're not, they're not that long lasting. They don't keep going. Uh, Most orchards use micro sprinklers or soaker loops. They've got to inspect them every week because some animal comes by and chomps on one or someone kicks one over. They've got to check those things because they're not as sturdy as regular pop-up sprinklers or stake sprinklers on stakes. Most sprinklers on stakes, or pop-ups, you can let them go for a good 5-6 years before you run into trouble if they're decently made. But drip systems, you got to check that almost every week. Now, initially, drip system is much more efficient. In the long run, once your yard's mature, the roots of all your plants run everywhere where you water, and then it's there's not as much of an advantage to run drip. Initially, though, it is more advantageous to run a drip system. So I know the last two houses I lived at, I had drip systems, and they're always out there repairing things. And sometimes the wife goes digging and she busts through several lines, So on farms they leave it on the surface so you can actually see where it is, but no one really likes that look either with tubes running all over the place. So anyway, sprinklers, run them for short periods of time over and over is fine. Now on farms, they wanted, up until they had drip systems, the normal way of watering a farm was either with sprinklers that they would run over the crop if the crop was short, or they would just flood the field every week. Now, they, once a week deep watering is what the farms always did in the old days. But now, when they did the studies, they found out, well, that's not very efficient. Plants are too wet a couple days a week, too dry a couple days a week, and nice for 3 days a week. So it's not the best way to water plants. The best way to water plants is daily or even more frequently. And when they did a study on the amount of water needed, they found out no. The more frequent you irrigate, the less water you need to apply to the plant during that week. Because when you flood it real deep, a lot of that water that's deep is lost. The plant's going to get it. So, and then they had another theory. Well, if you water deeply and frequently, you get a better root system, which is still promoted today. You water deeply and frequently, make that plant search for water, you get better roots. When they actually did the study in an orchard, total opposite. When they pulled the trees out at the end of the year, they're identical trees, one with daily irrigation, one with flood irrigation, same irrigation system, but heavily once a week. They pulled the trees out and they said the trees with the daily irrigation had significantly deeper roots. They weren't expecting that at all. So there are no disadvantages with watering lightly and frequently that we know of. And the ag department even told me that, in a production system, not say a native plant system, but in a production system, the water evaporates more slowly off the ground than it does out of the leaves of the plant. So if you have water evaporating, now the amount of water that evaporates out of the plant, plants don't really evaporate water on purpose. They have holes in their leaves that open and close to let carbon dioxide in. Carbon dioxide is what they need to photosynthesize So the holes open when the carbon dioxide levels drop too low, the water escapes. And the amount of water that escapes is how much water the air can hold that day. So if the air is 80% humidity, not much water is going to come out of those holes. If it's 20% humidity, lots of water is going to evaporate uh, out of there. But if water is evaporating off the ground, it makes the air more humid. The plants aren't using it as much. So the ag department told me there is no disadvantage of watering during the day. The ground's evaporating water, the plants don't need to. So they said, it doesn't matter what time of day you water. The only disadvantage in your yard is that if you have sprinklers going, if you use sprinklers and they're going in the afternoon, there's more chance of we have more wind in the afternoon than we do in the morning. So early in the morning, like 6, 7 o'clock in the morning, there's no wind. And the sprinklers hit their target. On a farm, it's not a big deal because it's such a big area. The sprinklers will just water. The next time they water, the sprinklers in the next section will hit that section. But for homeowners, watering in the morning is better. Now, the other thing about watering is that watering the leaves can cause diseases. But what we know about disease is that it's a timing thing. So when water's splashing on the leaves, no disease can attack it. The water just keeps. What diseases are usually spores that float in the air, and then the water droplet, they enter the water droplet and they germinate, and it takes them close to 4 hours for them to germinate in that water droplet and attack the leaf surface. And if the water dries up before 4 hours, no disease. So when it's raining, there's no disease, but after the rain stops, if the water sits there for half a day, you get diseased leaves. There's dew on the leaf in the morning. It can stay on until noon. You can have a diseased leaf. What Portland, the rose garden, found out is that if they turn on the sprinklers every morning to wash the dew off, they had very few disease. They had less bugs, less disease. So what happens on that is you have dew on the leaves. You wash it off, say at 5 or 6 o'clock in the morning, and as long as the water you washed off dries off within 4 hours, you messed up any disease that was trying to start in the dew. So they found out, yeah, if they just run the sprinklers for a minute early in the morning, cuts down a lot of the diseases that the roses were catching. So, grass lawns, it's got to be 12 hours before they catch disease. What rose is about 4 hours is minimum it takes. So a lot of different plants, there's different diseases, but most of them you can say, okay, if it dries off within 4 hours, you're not doing it any harm. This, if it stays wet too long, so you could, I guess, suppose go out there in 4 hours and close it down again. That's okay. So if you're using drip system, you just want to maintain your soil moisture 1 foot deep if you have a production plant. Just make sure you can keep pushing it thick. And every drip system's different, and every soil is different. So on some soils, clay soils, you put on 1 gallon of water, a lot of it spreads sideways. If you put on sand, it goes straight down. So you have to just check and see how deep, right where you irrigate, you push that stick in there and see how deep you can push it. If you can push it a foot, you're good. If you can keep it there, whenever if you have a set schedule, say you water 15 minutes every day with your drip, if you're keeping it at a foot, you're good. Now, if you water too much, if the soil is correct, there's no penalty. So watering too much is not a bad thing. I mean, all the other nurseries, most nurseries can tell you too much water, you rot your plants. But we've discussed that the last 2 weeks. There's no such thing as overwatering. It's all made up because we're growing plants in compost instead of dirt. If you grow them in compost, this has to get totally dry before the roots can breathe because the water that's in here is totally devoid of oxygen because of the decomposition that's going on. But if you grow plants in real dirt or in our soil that works the same, it can stay totally wet. the oxygen is not losing, the water is not losing its oxygen to decomposing material around it. Um, yep, cheers, cheers. Yeah. Well, there's a lot of different things you can put on a drip system that makes, like, there are emitters that just drip, 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 and then there are soaker tubes that drip every foot or even continuous line of moisture. There are micro sprinklers that spray water about 10 feet, but at a very slow rate. There are misters. I mean, there's a whole bunch of things in the drip system uh, tools that you can put on. Just know that emitters are probably the most reliable of those. Everything else can get messed up. Right. Well, most row crops, which are just small plants, vegetables, they use drip, the true drip. On most tree crops now, they're using micro sprinklers that spray out because they know on trees it's nice to cover at least 40% of their canopy area, the drip line. So most orchards, they have micro sprinklers set at the trunk spraying outwards. So it covers a bigger area than the original drip. Mhm. Mhm. Drip drip works on roses pretty well. Just drip, drip, drip. Depends on your soil. If your soil is too sandy, you might have to cover a big area. But on most soils, like back in the 80s, I just had one drip on each rose, and it was fine. Uh, in my soil, which was sandy loam, generally I would get about a foot and a half spread with the water with one dripper. If you have really sandy or gravelly soil, it won't spread far enough, but it was spreading a distance. Yeah, you want a micro sprinkler's better. I mean, my last house, we did some stuff that was real elaborate because I had to talk to this gentleman who was doing all kinds of weird things. He says, rain is more natural. So I actually had copper pipes, my drip system going running up the middle of that, and we had little micro sprinklers spraying over the entire yard. Just like you walk out there, it's like it feels like it's raining when you turn on your system. Those micro sprinklers, within a half a year, they're no good. They were breaking and everything. So we stopped that after a few years. But while we had that, it was really fun. I mean, he said, yeah, the rain is more natural for plants. They would only be watered from the top. So I had my micro sprinklers going over the tops of all my trees. And it was just like a little rainforest when I turned it on. You go out there, enjoy yourself in the middle of the summer day because it was just like a rain. It wasn't real heavy like sprinklers or just a light misting, for like half an hour. So, so anyway, lots of ways you can water, but the main thing is keep that soil moist about a foot, and you have to watch your competition. So the hard thing about doing vegetables around trees is that the tree roots get in amongst the vegetables and really suck it. If it's not if it's not a production tree on that, then you have to make sure you water the vegetables and those, ornamental trees nearby, or else keep the roots out of your vegetable garden. That's a real big problem. Um, I asked the farmer once who had 100-foot windbreak trees, what in the world do they do with those roots? He says, well, we actually run a trencher between the 100-foot trees in our farm every 5 years to cut off all the roots between them and the farm because those you let the tree roots get in there, they suck it dry. So they're always trimming them out. So yeah, if you're in, even just big shrubs can do the same thing to a vegetable garden. So watch that. And so there is a farm near the Sacramento that waters 18 times a day. They use computers and everything. They said they saved a lot of water. With the drip system, every hour they're replacing what the plant used the last hour. The more evenly you keep the moisture in the plant, the less cracking you get, the less splitting you get um, on the crop. So that's important. And just know too that the size of fruit is determined by two things: number of fruit on the tree and how much water they're getting. So if you get small oranges, you have either too many oranges on the tree or not watering enough. And if oranges get, especially navels, if they get dry once, so what fruits do? Tomatoes do this, orange, all citrus do this. The tree gets dry, the tree uses the fruit as a canteen, takes the moisture out of the fruit, and the fruit shrinks. And then you water it and it expands again, and then you let it dry and it shrinks again. If it rains on, so there's something called dry farming where they, a lot of wine grapes, they like them to get dry because the juices get more concentrated. The problem with that is if it rains on them, then the grapes go too much, if they're dry and then you water them all of a sudden with the rainstorm, they'll all just burst open. The same can happen with pomegranates, navel oranges. They'll burst if they get too dry and then a sudden water. So if you let them go dry, you've got to keep them dry. You can't suddenly just water them again if they've gone dry on you, then you split them.
Just gently,
Pardon?
just gently water, not too much water then, so they.
Well, there are, yeah. So like on wine grapes, they call it deficit watering. They water less than the plant really needs because they want to keep the grapes smaller and more, the juice more concentrated, but they have to watch the weather. That's said there's no way they can do it without computers to get the deficit watering proper. Well, that's watering. So too much water, in a container, plants generally water them every day. And the farms I walk through, they water pretty much every day too. So in the end, well, above, so the time of year when you do that is generally, so like here at the nursery, between November and April, we don't water, especially this year. I mean, last year we had 100 degrees in April and 80 degrees in February. We were watering, but normal, this is actually a little cooler than normal, but we won't start watering every day again until April. The days are longer, plants using water longer, and then it's generally warmer. Usually in April, we're in the mid 70s. And in November, we drop below the mid 70s normally. And then we just don't have to water every day again. Okay, fertilizer wise, on the back of this sheet, our planter back, we list all the nutrients or all the minerals that make up the plant. And humans are almost exactly the same. Plants, 17 minerals. We think maybe 18 actually. Animals, 16. So if you grind up your body, you have 16 of these 17 minerals in you. We're almost the same. So, so in plants, carbon is 45% of the weight of the plant. Oxygen is also 45% of the weight. Hydrogen, 6%. So carbon, hydrogen, oxygen is the bulk of a plant. Cellulose, which is wood, is carbon, hydrogen, and oxygen. So now plants get their carbon from carbon dioxide. I mean, it's a real crime that Congress let the EPA, well, who's behind this, label carbon dioxide as a pollutant. It's like, what in the world are they thinking? Half the world depends on carbon dioxide to live on. All plants depend on carbon. the carbon dioxide level in the atmosphere right now is 400 and something parts per million. In this room, it's about 500, 600 because we're breathing in here. The danger level for us is 10,000 parts per million. That's where we start suffocating. But plants operate better at way better at 400 than they did at 280, which was like 1900. They said if you drop below 200 parts per million, plants no longer can reproduce. We're getting low enough to where the plants are in danger of not being able to reproduce, which is crazy. I mean, they said if you go below 200 parts per million, they don't have enough carbon dioxide. They can't get enough carbon in them to complete their life cycle. So, so the fact that we've upped the rate artificially by burning coal, coal and oil to 400 parts per million, the plants are much happier and they're growing noticeably faster now than they were 40 years ago, and the deserts are greening up. Even NASA admits that the world is 20% greener now than it was in the 1960s when they first started doing satellite images of the Earth. It's greener, especially the deserts, because the plants don't have to open up their pores as long as they get the carbon dioxide in there that they used to. Open it for a second, they got enough carbon dioxide, close down, don't use the water. So they can farm now with less water than they could 50 years ago because of the carbon dioxide in the atmosphere is helping the crops save water. So there's a few plants, modern plants, that can get by on the lower carbon dioxide level, but they said most plants evolved when the carbon dioxide in the atmosphere was like 500 to 1,000 parts per million. So anyway, we don't have to apply these or don't think about it because that's carbon dioxide and the hydrants in the water you apply. So those we don't have to think about. And nitrogen, 1.5%. Potassium is 1%. Phosphorus is 0.2%. And then there's calcium, 0.5%. So these are the major nutrients. Normally we talk about nitrogen, phosphorus, potassium as the major nutrients. Calcium should be up there too, but most soils have ample calcium. So the nitrogen in a plant is basically just like us, all our cell membranes, our hair cell membranes, which is most of our body essentially, is nitrogen. So our skin is nitrogen, our hair is nitrogen. On plants, it's the membranes of their cells is nitrogen too. Just that thin membrane around each cell is nitrogen. It is, they need all these to grow. It's not a big deal, but nitrogen is the most limiting factor because the ground normally doesn't have any nitrogen in it. Typically, it's too low for plants to grow. They need a source of nitrogen, an active source of nitrogen, because the soil doesn't store it very well. Potassium in a plant is the same as it does in our bodies. It is the salt of our blood. So it's the salt that makes up the blood of our bodies. If you don't have enough potassium, you start fainting, or your nerves don't stop firing. This balances out the blood. In plants, it is the juice of the plant makes up the juice of it's the salt that makes up the juice in the cells. It's the salt that makes fruit juicier and bigger. So if you want bigger, juicier fruit, you need to make sure you have bananas, potassium. But it doesn't have any particular function in the plant other than balancing all the other salts out. So it is the juice. Phosphorus is the energy transfer molecule. So as people tell you, well, you got to up the phosphorus to make a plant flower or make roots or stuff like that. No, you don't. You need less nitrogen. So when the plant's growing too fast, it doesn't store enough energy to make flowers or fruit or, you know, it's strange they have you put on phosphorus when you just need to stop doing this. So, so phosphorus for energy transfer molecules. So it's the way. So plants make energy by capturing sunlight. They make the sugar molecule, which is energy of the sun. And when the sugar molecule is broken down, it energizes the phosphorus to make a molecule called ATP, adenosine triphosphate, and that runs through your blood system or through the plant's system to power up anything they need to do, repair a wound, grow something, do something. Phosphorus is the way they transfer the energy from sugar. So our blood system, we transfer a little sugar, um, and when it breaks down, it creates an ATP molecule, and that powers up the muscle to do something. So phosphorus is an energy transfer. Calcium is a part of wood. So plants that are woody plants, they need quite a bit of calcium. Calcium is also essential for finishing off fruit. So if your tomatoes don't have enough calcium in them, they get that hard brown spot on the bottom. And you have to spray calcium right on the fruit. I mean, it just happens on the big tomato. You know, tomatoes in nature are about that big. You got a tomato that's this big, plant can't supply with enough calcium. It's not easy for that plant to do it. So you have to spray the calcium right on the fruit to prevent that hard brown spot. Same thing happens in peppers. Apples get hard brown spots in the flesh. So that's the calcium. Our fruit tree supplier keeps telling us to recommend that people add gypsum, which is calcium sulfate, to their fruit trees every year. Brokaw Nursery, which sells our avocado, says they put 35 pounds on each avocado tree every year. So they want you to put a lot of calcium on there. Gypsum is one form of calcium.
What happens if you don't put that calcium on your avocado?
Well, our soils have quite a bit of calcium in them, but they always want you to put more. They say calcium helps prevent root rot. They don't know why. Calcium, so gypsum also, on the other hand, helps get rid of salt. So sodium is bad for plants. Um, Calcium is not. So if you put a lot of gypsum on the ground, like before the rains came, our ground was loading up with all these salts from our tap water. Tap water's got a lot of magnesium, other salts in it. And if you put gypsum on the ground, it releases the salts. It takes the place of the salts, and gypsum is a friendly salt to plants, whereas sodium and the other salts are bad for plants. So you put this on there, when you water it, then those salts are free to leach away, replaced by the calcium, which the plants don't mind. So that's another reason that we apply gypsum is to get rid of salt. If you have enough water to flush it out, that is. Okay, so these are the major nutrients in plants. Or major minerals that make up plants. And everything else is pretty minor. So you got magnesium 0.2, sulfur 0.1, iron. I mean, 30 years ago, everybody was pushing iron on your plants because they were turning yellow. It wasn't iron. Iron 0.01, chlorine 0.01, manganese 0.005, boron, zinc. I mean, these are such low numbers. Going Plant Lab in Irvine told me once they had an orchard that was zinc deficient. All I did is took a galvanized nail and pounded into each trunk of each tree and cured them. That's how little that is. Uh, one little nail is coated with zinc. So most of these minor nutrients are involved either in a chlorophyll molecule or in some enzyme that creates something in the plant. So the bulk of the plant is carbon, hydrogen, oxygen, then nitrogen, potassium, but all these more involved in either the chlorophyll molecule. So if these are missing, your plants turn yellow because the chlorophyll molecule is not made properly. A lot of these you can tell by looking at the color of the plant. Well, that's hard. I mean, the guys at the soil and plant lab tell me, they're always guessing on what, they go to farms and they see the chlorotic foliage and they take it back to lab and they're always guessing or betting on what mineral it is, and they said they don't get it right too often. But if you put on the wrong one, you can really mess up the plant. That's the thing. There's a lot of these minerals, potassium, magnesium are one special. So magnesium is found in Epsom salts. And for some reason, there's a lot of people going around town, put Epsom salts in your plants. Well, this is a micronutrient. And unfortunately, Epsom salts and potassium, magnesium and potassium go into the same channel into a plant. And if you overload one, you block the uptake of the other. So you put Epsom salts in the plant, you can send that plant directly into potassium deficiency, which is way worse. So you have to put them on the right, you don't want to overdo something. And when people try to put Epsom salts in the plant, don't do it. Or if you do it, just do like a teaspoon and never do it again. I mean, they just don't need much of that stuff. So most of the minerals here, you put them on your ground or in the soil, they don't move too much. The only thing that really moves in soil a lot is nitrogen. That thing either evaporates as ammonia or leaches through the ground. Most other nutrients don't move very fast. Like if you put potassium on the ground, you just put it on the surface. They say it takes 3 years for that to leach its way down to where the roots are. So you don't see the effect of it for 3 years. But then it's there for a long time before it's gone. So most of those minerals tend to build up. So you have to be careful when you fertilize. Now, fertilizer-wise, nowadays we have all these fancy things. In the old days, when I was a kid, my dad just had three things, three simple fertilizer. Simple fertilizer, just one ingredient. So the three things he had, one was cottonseed meal, one was blood meal, and one was bone meal. Now, it was cow bone, not fish bone, but bone meal, cottonseed meal, and blood meal were all that the nurseries used in those days. And between those three, they had everything. I mean, cottonseed meal really has just about everything a plant would need just because it's ground up seeds. So you figure a seed for a plant got the embryo in it and it's got all the nutrients that seed needs to grow initially. Everything that seed needs to grow. So anytime you grind up a seed, you've got pretty much every single mineral that we list in it. Well, I forgot to mention, some of the people growing plants in artificial soils now are finding out that the plants do a lot better if you have silicon on them. You apply silicon spray. The nature soil is pure silicon. So it's like, okay, if they stop growing in dirt, now they got to apply the silicon to the plant. It's just maddening what people are, what they're doing. Finding out, that if you don't use real dirt, you got to apply this. Anyway, So this is all we used to use. Now, this is, dried cow's blood, and bone meal was crushed cow bones. We found it later that cow bones don't decompose far enough to help plants the first few years. So it was pretty useless to apply bone meal uh, in our situation in nursery because we only had the plants for 6 months. It wasn't long enough for the bone meal to ever become used by the plant. But in a garden, eventually your plants will get bone meal. But for the phosphorus, there's probably calcium in it too. Yeah, 14%, higher than the phosphorus. So the blood meal is nitrogen, and it's among organic fertilizers. This is one of the fastest forms of nitrogen. So most organic things, like seed meals, it takes a few weeks for nature to break it down and get the nutrients back into the plant, and sometimes longer than that. So that's the disadvantage of organic, is that it takes a little longer for things to work. But um, the most important thing about organics is they feed the organisms that are in the soil that are breaking them down, that keep the soil alive and fluffy. So these things are actually feeding the soil. And then when these things get broken down into the smallest back down to minerals, then the plant gets. So, so these were the original simple fertilizers that we used. Now, during the World Wars, they had a lot of bomb factories to make bombs, and it turns out that what makes explosives is not as a compound with nitrogen. So after the World Wars were over, World War II was over, they had so many factories that were set up to make nitrogen fertilizers. Well, nitrogen fertilizers, some are really explosive, so you have to be careful. But so in the 1960s, we sold lots of ammonium sulfate, which is the straight nitrogen 2100, and this is not explosive, but it was cheap to make it. We sold these for $2 a bag back in the 60s and 70s. Now they're like 33. Everything's gone sky high, $33 a bag. But it's still, this goes a long way. The disadvantage of chemical fertilizers like this is you put it on, they work right now, and then they're gone in 2 weeks. It just dissipates too fast. Whereas if you have an organic source of nitrogen on a constant meal, it decomposes slowly, so you have a much longer period of use. This may give you nitrogen for months and months. This one only for a couple of weeks. So you have to apply this more often, and this gets in the groundwater and pollutes the lakes and rivers too. So it's better to use an organic for several reasons. Now, in the nursery industry, the most popular fertilizer used for growing plants is osmocote. So this is a chemical. It works immediately. So the next day it works, but it is a time release. So there's little plastic beads in here, and each plastic bead has fertilizer in it, highly concentrated fertilizer. And as it gets moist, the beads expand and the pressure forces the nutrients out at a slow rate over a 6 month period. This has, now this is the most popular one. It's got, of the minerals we need to apply, which comes out to, other than carbon, hydrogen, oxygen, that's 13 minerals. They say that nickel and cobalt, anything that looks like dirt has that in it in sufficient amount. So there's like uh, about 11 minerals you need to add. This has got, I think it's got all 11. It's got 11 minerals in it. So this is very complete. So something like this would have all 17 minerals in it. This has the most important 11 minerals in it. So the EPA had some researchers check up on nurseries to see how much they were, because they were blaming nurseries polluting the rivers near big nurseries. So they wanted to see how much of this was leaching out. They said it was lower than the EPA wanted it. So they couldn't blame the nurseries polluting the rivers and lakes because they said that by the time the plants were ready for sale 3 months later, 50% was still inside the bead. 20 more percent was 20 or 30% was in the plants, and very little of it, less than 10%, was coming out the bottom holes of the pot. So this is a very nice way for us to fertilize because it works immediately and it works for 6 months. When I was a kid, pardon, just you're supposed to mix it with the dirt.
Oh,
I mean, when I was a kid, my dad told me, the rules was fertilize once a month, water once a day, you're fine. So with the organics, you would have to apply it every month, which is mean. I mean, I did that for a while. You have to go out to every plant in your nursery, put something in every month. That's a lot of work. So we like this much better. Now we know in the long run, especially in a homeowner situation, you want to go organic. Now the ratio numbers on this product are 15, 9, 12. We have a problem in that most landscapers don't realize. So most landscapers and contractors and gardeners aren't real high up on what fertilizer should be. I mean, U.S. Department of Agriculture sent us letters saying that the typical crop growing in the United States, the ratio should be around 6:1:4 between nitrogen, phosphorus, and potassium, NPK. The ratio should be right around there, or 6:2:4, 6:2:4, might be the right ratio. And that's how it is in plants. That's how it is pretty much in our bodies too. Uh, but a while ago, like 20 years ago, 25 years ago, some gardeners thought, or some journalists maybe said this, if the numbers are the same, it's a balanced fertilizer. So they're promoting things like 15, 15, 15, or 20, 20, 20, and telling everybody that's a better fertilizer because it's balanced. Like, no, that's balanced. This is way off. And these were all chemical fertilizers. Get the numbers at this high, it's got to be a chemical. Do that. And what we found out, okay, so in plants, the way that most plants get nutrients from organic matter, and in nature, primarily dead leaves. A dead leaf has everything a living leaf needs in it. So in nature, I should have done this first. So take a tree, roots down here, got your 5 inches of dead leaves piled over the surface of the ground, and that's where the nutrients are. The system that most plants use, 95% of all plants, have a fungus partner in the ground called a mycorrhizal fungus. This fungus actually attaches directly to the roots or surrounds the roots. There's some that attach and some that surround the roots of the plants and go up and eat these leaves. And they said until the 60s, when they invented electron microscopes, they couldn't tell that this fungus wasn't the root of the tree. And that what they've said now, the U.S. Department of Agriculture said that what they thought was 80% of the roots of the tree was actually a fungus growing on the roots. They couldn't tell. They couldn't tell because they couldn't see the fact that it was not the roots of a tree because it was attached to the roots. So they said 80% of the roots of most woody plants are actually this fungus that goes up into the dead leaves and breaks them down and brings them right back in the plant. They said a leaf can drop off the tree, nutrients in that leaf can be redirected back into the same tree within 90 days. Mm-hmm. They said it's more efficient than composting. So compost you got this bacteria that eats this stuff up. When the bacteria dies, then the nutrients go back to the plant. But that may not happen for a long time. Whereas mycorrhizal fungus, this is its job. It's a symbiotic partner of plants. In return, this mycorrhizal fungus gets sugar from the tree to make its body. It's made out of cellulose too. Cellulose is a sugar molecule that's rearranged. So this fungus gets the cellulose from the tree, and it takes the nutrients here and gives it back to the tree. When it's breaking down the stuff, it's taking energy out of the leaves, the dead leaves, also.
Do the mycorrhizal, do they also search for nutrients for the plant if they're, go out and?
Well, they make their hyphae, their roots go out too.
Yeah.
Now, what they're telling us now is that in nature, this is the king of the forest. They even have 100 trees connected to one big mycorrhizal fungi, and they have documented this huge organism in Oregon that's like 200 yards across. It's one big fungus. And they said the weird thing about mycorrhizal, or the thing that they noted, is that electrical impulses can travel through it. So they said when you're walking through the forest, the trees know you're walking.
Mm-hmm.
The mycorrhizal fungus can tell them that you're walking through that forest. And this mycorrhizal fungus also can connect your entire garden together if you leave it alone. If you leave the soil alone, this fungus will attach to every plant in your garden and share the water and the nutrients. So they already did studies with trees. They said 70 yards from the river, the water gets transported from the river up to those trees 70 yards away through the mycorrhizal fungus system. So they share water, they share nutrients. Once your plants connect to this, they're all set. My first home I bought, 20-year-old house, we were surprised that only about a third of the sprinklers worked, but the yard was still green. And we couldn't figure it out. And that's why, because the 20-year-old yard, there's mycorrhizal fungus all connected all the plants together. So even though only the sprinklers here and there are working, the yard was staying green.
Is this also part of the argument for no-till agriculture?
Right.
You could completely disturb that network of
Right.
hyphae. Really.
It messes them up. So no-till agriculture, there are some crops that don't like this. So the crops that don't like this in nature are the crops that are the pioneers of a new patch of ground. So if they have a landslide, the first plants that come in are considered the pioneer plants. A lot of them are in the Brassicaceae family, cabbage, cauliflower, broccoli. They're in that family of plants that is a pioneer plant. They don't like the mycorrhizae around. They'd rather gather nutrients on their own. A lot of grasses are that way too. So grass weeds, mustard, some other plants, they don't like the mycorrhizae around. They'd rather do it on their own. When the mycorrhizae come in, they lock the nutrients and give it to the plants that they are connected to. So in a forest, you don't see many weeds. The mycorrhizal's taken over the nutrients cycle in the forest, and you don't see many weeds there. So
I'll never walk the forest again. I'm the same. Is there any basis for this idea that certain plants don't like to grow next to others? I did this with my grandchildren, did a study of which plants don't like to be by other plants and which ones do like to be by certain others.
Well, certainly the Brassicaceae, the cabbage, broccoli, cauliflower family, wouldn't want to be near a plant that has mycorrhizal fungus
That's
on
what
it.
I was hearing you say, yeah.
Ferns, I don't think have mycorrhizal. Well, some ferns do. Orchids don't. Certain plants don't use it. Some grass crops don't use it. So that would make sense, but most plants would rather have this system in place. So mycorrhizal fungus is hurt by high soluble phosphorus. So if you have a chemical source of phosphorus, like this is 2020, and you keep using it, keep using it, keep using it, you can wipe that out. Because they're mycorrhizal fungus, generally that's their job, is to get the phosphorus out of the ground into the plant. And if you put on something that's too easy for them, it just burns them out. So Miracle Grow used to be 15-30-15 because in artificial soil like our potting soil, the plants have a hard time getting the phosphorus, so they used to overload with phosphorus because there's no mycorrhizal fungus in a pot. But apparently somebody told them that was wiping out the mycorrhizal fungus. So they really changed about year 2000, maybe after 2000, Miracle changed from 15-30-15 to like 12-8, 15-8-12, or something like that, down to something that's more reasonable. So, the companies are learning what to do. So, as far as the plant's concerned, if it picks up a chemical version of fertilizer or a organic version, it's no different. Just know that the soil is much healthier if you do organic, because it keeps all those soil organisms alive to keep the ground fluffy and healthy. Whereas the chemical ones, if you really go astray with the numbers, you can sterilize your soil. So in the long run, it's better to go organic than chemicals. But in the short run, these work way faster. Yeah.
Isn't that more natural?
What was the original part of the question?
So there are some plants, and we want to harvest.
Right.
Isn't that nitrogen is the more the better?
Right.
So the more nitrogen you put in, and the more leaves.
True. If you're growing lettuce or cabbage, you want more nitrogen. True.
Okay.
Yeah. But again, you need all these minerals for every part of your plant. Just you don't need as much. I mean, nitrogen is again the most common mineral you're not going to have enough of. So that one always has to be added pretty much every year, or have a good source of dead leaves on the ground. Okay.
This mulch replace the dead leaves on the ground.
Not as well as dead leaves does. So dead leaves are better. Like this garden straw, which is dead weed, would be more ideal for say a garden than say wood chips. Yeah, most of the things that we sell are kind of some kind of bark product, and bark really doesn't have that much nitrogen in it, so it's not the ideal. But since it's just hard to get dead leaves, I mean, garden straw is one of the few ways we have it. I mean, this garden compost that we sell says they have green waste in it, but I don't know what that means. If the green waste is just chopped up trees, that actually is, grass clippings or leaf clippings, whatever. It doesn't say. That's one problem. I mean, most of these places that sell bulk materials in bags, they have to put on the bag what's in it, and they can't. A lot of times they don't have a good supply of dead leaves. Like down in the deep south and in Florida, they do sell pine needles as mulches, and those are better, would be better than the ground up bark would be, but we don't have enough pine trees here to do that with. In some areas in Florida, they also sell eucalyptus leaves as mulch, and that's fine too.
I thought one is on top. So much.
Mm-hmm.
When we use that one.
Your guava tree is telling you, leave my leaves right here.
I have so much.
Yeah,
I just can I use it on
yeah. Well, generally all the leaves are roughly the same material in them. So they're usually as good. But most trees in nature, they want their leaves to drop down here. Because they depend on that nutrient source for themselves. So if you take the leaves away, then you have to replace it with something.
So then our gardeners that are blowing them all away, we should not do that.
True. I mean, doesn't look good as far as they're looking at it. They don't think it looks good.
Mhm.
So what can you do? I mean, but yeah, it's better if you leave it in place. In nature, they want it to be luscious.
I have a row of gardenias and camellias. Would that apply to? And they're about 8 to 10 feet, so they're massive. I'm very successful with them, but I've been cleaning them up. So should I leave the leaves there?
If you don't want to fertilize, if you leave the leaves there, you won't have to fertilize.
I'm gonna have a couple of really large pine trees, so I have a lot of pine needles. I also planted some avocados. They don't have avocado leaves yet, but they're done. So just look at you make the pine needles.
Yeah. Oh yeah. Use the pine needles underneath your avocado tree, and it's good. Yes.
How much if, okay, so let's say we don't have enough leaves and we need to put some kind of mulch. How many inches or how much?
Well, the coarser the mulch, the deeper you can go. So there's a farm up north that goes 1.5 feet deep, which is deep. So this is an orchard, and they said they just call up the local tree trimmer. So if you want to get cheap mulch, I heard there's an app you can put your name and address in there, and the next tree company that chops up trees and bushes in the area will just drop a load of chopped up stuff for free. Just be aware that it's like 10 cubic yards at a time, which is a huge pile. But this orchard did that. They called up all the local tree companies, and they maintain it 18 inches deep in their orchard. And the nice thing about that, well, they do say they have chickens in their farm, so they said they don't have to buy any fertilizer, because all this dead stuff serves as fertilizer too, plus the chickens. And they don't have to water anymore. They said that they got this idea 40 years ago. They were, in the summertime, they were having to water their apple orchard pretty much daily in the summer. But they noticed the forest next door to them, no one ever watered them. They walked through the forest in the morning, and that deep leaf litter would just soggy. Overnight, if the temperatures are cool and the air is humid, then the moisture condenses into that stuff at night. So they started doing that in their orchard. They said they haven't had the water since the 1980s, or fertilized. So that's one thing. If you put a deep mulch layer on the ground, you can generate some moisture. They said they saw the same thing in Texas in the 1980s. They're having a real bad drought. They had all these dead plants along the highway, so the highway maintenance people were just taking their chippers and chipping up the dead plants and making a big pile on one side of the road. They said then one side of the road greened up. They couldn't figure out what was going on. Because all the plants are drying up and dying, and then when they piled the mulch on one side, that side of the road greened up. Of course, Texas is, even during the drought, it's more humid than we are. So, but that, it doesn't hurt.
On the mulch, so if we're putting as much mulch as we can, how far from the trunk should we keep it away?
Nature, there's no one cleaning it away. It can be really deep. So there's a lot of people will tell you don't put mulch through the trunk because you're going to rot it out. That's because they're going to plant some compost and they're rotting anyway. So they have to rationalize what to do to stop the rotting. So one way, but if you have a lot of mulch around the tree, you do get less oxygen to the trunk of the tree. Anything you do to get more oxygen to compost soil will help keep it from rotting. So they have to make up all these rules to help prevent rot. The only plant that doesn't like wet trunks is citrus that we know of. You try to keep the mulch away from the citrus trunk because it can rot. It stays totally wet all the time. But any other plant, we don't. They said in nature some of the leaves can pile up 3-5 foot deep. So yes.
I always worry about getting mulch from, like you said, from some guys who are cutting down trees because of disease. introducing a disease into my garden or to my other tree.
Possible. It is possible, not likely though. So, like they did a study on roses. Uh, they said once the disease leaf hits the ground, the organisms on the ground pretty much destroy the disease spores. So there's a lot of activity on the ground that's killing off the diseases. They said with roses, there's plenty of spores floating in the air. Don't worry about the stuff on the ground. 'Cause in the old days, they used to sterilize the rose bed every once a year to kill all the disease spores, and they found out it absolutely did nothing because the living spores were just floating in the air. They come right off the diseased leaves, float in the air, land back on the plant. That's how you get your disease. You don't get it off the ground much. So too much biological activity in the ground. So, so not a big worry. I mean, there's certain plants like if you grew dead avocado trees underneath in your avocado orchard, that's not probably not good. But most of the things we don't worry about it too much. I mean, the weird thing is, they sell bark as mulch, which is not very natural in nature. And when trees die, they don't suddenly fall into a million pieces. That trunk can sit there for decades, even centuries before it decomposes. So there's something wrong about using bark or wood as mulch anyway. It should be leaves. Okay. Um, the crop rotation. Well, okay. So the other thing that mulching does is it insulates the soil. So what they did a study in an orchard in Texas. They said on a 90-degree day, if you have bare dirt, the soil temperature a foot deep can be 120 degrees. Too hot for the roots to really live there, so they have to go deeper. But most roots are happier close to the surface where they can breathe and get their water. They said if they covered it with 3 inches of mulch, 85, and 85 is perfect temperature for roots. That's the ideal temperature for roots to be 85 degrees. So 3 inches of mulch on the ground is almost essential to keep the plants looking from being cooked in the summer. So if you have a rose garden, no mulch on the ground, the roses look cooked when it gets warm. If you have mulch on the ground, they look like spring. So make sure you keep that ground covered or, put plants there, other plants on the ground around them to keep the ground cool. You don't want exposed dirt around your plants if you can help it.
Okay.
Unless you're trying to grow a crop in the winter, bare dirt in the winter warms up better than covered dirt does. A lot of the strawberry fields use clear plastic. It really heats up good underneath that clear plastic, better than it does in their black plastic.
That's interesting.
Okay, so crop rotation. Um, so crop rotation is related to why plants die. So in nature, what they found out is that trees, which are the longest living plants, can stay healthy as long as they can keep growing longer roots every year. So every year they grow roots, and every year those roots die, and then they grow new roots, and those roots die, and then they grow new roots, and they start building up this area near the tree with all these dead tree roots, and they don't want to live there anymore. They have to keep going further out. So every year they'll grow out 2 or 3 more feet, get to a clean area of the soil, and next year they'll grow even further out, and the year after that they'll go even further. Eventually, they can't support the root system anymore, and then the roots have to live among the dead tree roots, and the tree declines rapidly during that stage. So they said when say take a redwood tree, it can live 4 or 5 thousand years. First 4,000 years, the tree is very healthy. It kind of looks like this. And as it reaches its maximum root size, then the tree shape changes to more like this. And then when it starts dying, it dies fast. It may take less than a century for it to totally die, which is real quick in this tree's 5,000-year life. But that's what trees do. If they run out of root space or they can't support a bigger root system, then they decline and die. So with the plants that we're growing, a lot of them don't live very long because they can't grow roots very far. So let's take, well, annuals die within a year, but let's take a perennial like a dahlia bulb. So dahlias, some of them grow 3 feet, make their flowers. They grow the root systems in here. Within 3 years, they kind of used up all of that space where they can stretch the roots out, and they start declining. You want to keep the dahlia going, you dig it up, move it a foot, put it back in the ground, and then go for 3 more years. So on, well, irises travel. That's why they're traveling. They're trying to get away from their dead roots. You know, you have Shasta daisies, they're moving. They move through your garden because if they stay in the same spot, they die in that spot. So the living parts keep on going further and further away. So dahlias 3 years in one spot. They'll die if you leave them there. They won't if you move them. You don't have to move them. You can just pull them up, put new dirt in there, and put them back. I mean, we have one supplier that told us here every winter they take the perennials, pull out a pot, shake the dirt off, put new dirt in the pot, put them back in. Keep them going. You know, a little pot, they run out of root space a lot faster than they do in the ground. So every year they would do that with daylilies, with penstemon, with other things that they're growing in their containers. You got to renew the soil. You know, you can rotate them that way. You can rotate the soil just by putting new soil around them.
If you put another dahlia in that same spot, that won't work.
Right.
So what if you're going to different?
If it's unrelated, it doesn't affect them.
So an olive happy?
Well, it's just like people. If someone killed someone in your house, they can grind up the body in a million parts, spread it all over your house. There's not much of your house, but it'll make you sick. If you did a monkey, it's the same thing. A monkey's body would make you sick. Even if it's just pieces of one arm, it'd make you sick. It doesn't take much if it's related to you to make you sick. If you kill a frog, you won't notice. Kill a fish, you won't notice. It's not related closely. So the same thing happens in all plants. If it's a related plant, it's going to mess them up. If it's unrelated, they don't care. So in forests, generally there's, you know, tree falls down, you get weeds growing for a long time, and then you get bushes growing, and then 20 years later you get the same tree growing back. Now, if you have a fire, that's a different story. So if you get a wildfire going through your forest, it sterilizes the ground. So they said a wildfire can sterilize the ground close to a foot deep, which is where most of the roots of the trees live. So in temperate climates, we get wildfires. And so you have a whole forest of, say, fir trees. That thing burns down, fir trees grow right back. In the tropics, there's no wildfires. So like they say down in Mexico or in Amazon, there's just hundreds of species of trees growing in their forest. Because when one tree dies, for a huge area, like 70 yards across, the same tree can't grow because that's the decaying root system of this tree. They do say most of the trees in the Amazon look alike, but they're all different species. They just grow like this because it's the same environment. But they said, yeah, it's a huge number of different trees that grow in a rainforest versus a forest where the fire burns the trees up. They said all the trees at the entrance to Yosemite are all dying because they haven't had a wildfire there for 100 years. So they're just getting too old. So they're getting all of these diseases. The park ranger says, well, we can't do anything about it unless we burn the whole place down. You know, they're not about to do that. So what will happen is the species of trees will have to change. Something else will grow. They're having the same problems in the lower Appalachians. They're controlling the fires well enough. They said, oh, all our oaks are dying, replaced by these ugly pine trees. Well, burn it down. got to burn it down. So in your own yard, when you're growing vegetables, it's nice to have different beds that you can rotate them through. Farmer friend of mine, AJ Kawamura, who runs the Orange County Produce, they told me that they're on a 10 crop rotation cycle, so they don't grow the same crop, but once every, or anything related to it, once every 10 crops. Now on this, we have the vegetable family, so you know which plants to rotate. So if you have, say, it's nice to make at least 4 different beds in your garden. Then so one year you put all your Solanaceae, which is tomato family, tomatoes, peppers, eggplants, potatoes in this bed. And then the next year move it to this bed, next year move to that bed, next year move to that bed, then back to this one. We were there leasing land from them for 4 years. We did not see them plant the same crop in the same plot twice in doing those 4 years. So it takes at least 4 years for that 10 crop rotation cycle they were on to get back to the same crop. So it's nice to do that in your yard too. I mean, three beds is not bad. 4 beds is better. You try to grow the same plant, the same bed over and over and over. Like my wife and I just checked it out. We grew a tomato. First year, absolutely fantastic. Second year, about 80% as good as the first. Third year, nothing. It would grow and then die.
Mm-hmm.
And then you couldn't put a tomato there for another 3 or 4 years. So it's better to keep shifting, and keep them separate. Now, there's a way around this. So there's a group of people called the square foot garden. Where they plant different crops. Each plant is a different plant put apart. But they found out the only way they can do that is if they can pull the entire root system out of there after each crop. So they had to modify the soil they used. They couldn't use real dirt because you pull them out, you're breaking off all the roots, and all the roots are dying in the ground. So they had to use a lot of vermiculite and perlite and peat to do a square foot garden. So that when you pull the plant out, you're getting the roots with it. You're not leaving broken roots in the ground behind this plant. So they really had to modify what they did, because if you put a tomato next to corn, next to squash, and do that every year, yeah, and in a few years you can't grow anything in there. And you got all these dead bodies in there mixed up. Now, the one reason why they like these square foot garden, we have a different plant, is that disease and pests have a hard time moving around that garden. So the disease that attacks corn can't suddenly attack the squash, can't attack tomatoes. So it works that way. It works because you don't get the pest problems you do when you have monocultures, but then you're stuck with not even being able to rotate. Now, of course, you can put everything in little pots and put them real close to each other and do the same thing and have the soil separate.
Could you divide one of the raised garden beds and do like half tomato,
Sure.
one half and family and stuff?
Man, just put a solid divider in there so the roots don't cross it. Yeah, just keep the roots separate. That's the thing you're trying to stop is the roots. So.
The other things that you're worried about, I mean, what about things that can move, like nematodes? You know, tomato over there and, move it over here 5 or 6 feet. Since every square foot is about $1 million in county rotating crops, it's difficult. In fact, 40 is back 40 inches.
Yeah.
You know, let's say I had a tomato there last year and I'm moving over here. Is that a rotation?
Yeah. Well, if it's
Nematodes aren't just gonna move you on over here and attack.
they could. I mean, nematode's more of a property of your soil than it is necessarily the plant. I mean, we do have some nematode controls now, but yeah. So anytime you have a crop there and the nematodes start attacking it, then if you plant a crop directly in that spot again, so the roots on tomato plants will probably only grow out about 2 feet from the trunk. So.
What do the farmers do, like in the Midwest, to try to the South?
Well, the grass plants can handle not rotating. And so grass plants are meant to grow in the same spot over and over and over. That's why your lawn looks good for years and years. I mean, the first time you grow a lawn, it is prettiest. And then you pull out and plant it lawn again, it's not as good the second time because of the dead grass plants. But grass is meant to live in the same spot longer than most plants are. So wheat and corn, I mean, still though, every once in a while they'll have to take and grow soybeans or cotton or something else because it does mess them up eventually. But grass crops are the least affected by not rotating crops. I mean, there's a farmer in Japan that back in the 50s, he wanted to make, because he was a plant pathologist, and he says, all we're doing is trying to fix problems that occur. Let's find a different way to farm. So he took over his dad's farm and said, well, let's try to make it lowest possible input and see what we can do. And what they would do is they would grow rice and oats. Rice in the summer, oats in the winter. And they would just, once the rice crop was harvested, they would just chop the chaff down and lay it on the ground and grow it's barley. Grow the barley in that. And when the barley died, they would just grow the rice in that. They would just leave the dead bodies on the ground and grow it that way. But we don't have enough. So he was quite successful doing that. He said, yeah, don't have to spend the money and throw all the stuff in the dump. I don't have to spend all this money and collect it all. We just leave it in place and let the plants grow on it. Now, we don't know, we don't have enough experience on how this is going to work yet because farmers just haven't done it. They haven't recycled their dead plants. Now they're being told to. So there are farms now that they harvest their crops, take all the greenery and move it to a big warehouse and compost it in there and then spread it back out. They don't have enough information on how to leave it on the field yet and let it just rot and see if that'll work. I mean, that's what's not been done yet on a large scale. So like it's up to everybody to figure this out. After your tomato crop's over, can you just pull the plant out and leave it there and grow other plants in it and not affect the other plants? How is that going to work? Because that's the ideal way to do it. That's how nature does it. Just leave the plant there and grow something else. So that's something to explore. We'll see if there's research on that in the future.
I have two things that Latvia and cucumber, if you are rabbit, and I do cucumber again.
It will not grow. So cucumber, they said, is the most sensitive crop to not rotating. The most sensitive. And I tried it. I did cucumbers one year, they were great. The next year, it wouldn't even set one flower. Just died. So cucumbers are supposed to be the worst plant not to rotate.
You have to rotate.
Have to rotate cucumbers properly to get a crop again. I mean, tomatoes a lot of the modern tomatoes are bred to live among the dead. I mean, this Beefmaster was bred to resist all kinds of root diseases from the last crop. So they were bred to do that, but cucumbers apparently are not. I mean, the better tomatoes are not bred for that purpose, they're bred for flavor. But a lot of the popular ones back in the 60s, because people didn't understand crop rotation well, yeah, you get a hybrid tomato that's resistant to verticillium, fusarium, nematodes. It's all the things that happen after the last crop is pulled out. It resists that. So it can grow in the ground for many, many years.
So after 4 years, then I can do it.
Yeah, I mean, I asked my farmer friend, why do you grow cabbage? You can't make any money on cabbage. He said, yeah, a lot of these crops we do not make money on, but you have to be part of the rotation. I mean, there are farms that don't rotate. So you see where there's a strawberry field every year in the same spot. They use clear plastic, they're fumigating the ground, they're sterilizing the soil, they're killing any dead organisms that are in the ground to be able to do that. Now, fumigants are being gotten rid of slowly. So the farmers will have to eventually not do that anymore. The organic farmer does, they do that 10 crop rotation cycle to get back to strawberries. But the conventional farmers who use clear plastic still do the fumigation so they can replant the same thing every year. Now up in Sacramento, they used to grow rice every year, and the way they would treat the field is after the rice was harvested, they would just burn it. And then Sacramento citizens said, "No, stop doing that." So they stopped burning it, and now they have to rotate their crops. They cannot grow rice in the same crop twice because the dead rice plants, the remnants, are preventing it. So burning it is one method of, they won't let you burn your crop in your backyard, I don't think.
Burn off the sugar.
That's for processing the sugar cane. That's for processing the sugar cane.
Oh,
Yeah, they do that because sugar cane leaves are so sharp. There's no way you can harvest it otherwise, so they just burn it off. It doesn't burn the canes, it just burns the leaves off.
I figured maybe they were sterilizing the ground or something.
They probably rotate their crops. But yeah, they do that to get rid of the leaves.
I'm thinking, so you're talking about the white plastic. So after my crop is done, say my tomatoes and things, could I put the plastic on and do the same thing?
You don't have any fumigants. Now there is something called soil solarization that can work, but we don't have the weather for it. So soil solarization is where you get clear plastic, get the soil moist underneath it, and then you tuck the edges of the plastic down so the sun will heat it up.
Yeah.
They said you have to have 2 weeks of 95-degree weather to do that. So it works in Fresno. We usually don't get the heat.
Yeah.
And it only sterilizes about this deep. So we don't have the right conditions for solar solarization. You have to use chemicals to sterilize it properly. The reason why they got rid of those products is we used to sell a product called Vapam, which was a soil sterilant. You spray it over the ground, cover with plastic, it drains these gases that kill off everything. Then you pull the plastic off and let it aerate out, and it's gone. Well, Southern Pacific Railroad dumped a boxcar into the Sacramento River in the 1980s, wiped out the entire river. In order to get the vapam out of the river, they had to aerate the river to get that poison out of the water. After that, they said, "Oh, no more vapam." Thanks Southern Pacific for that. But they've had other instances where people weren't handling it properly and people died.
So one solution to the rotator problem is just to use the pot.
Yeah, you can put plants in containers. So our soil, our potting soils we sell are permanent soils. Most potting soils use them once for 3 months and they're no good anymore. So you just throw them away and add new potting soil. Our potting soil is more permanent, but you do have to watch the rotation in there. You can also double dig a bed. So in areas where the soil is moisture, it's easy to double dig. Around here, it's not easy to double dig anything. So double digging, which is common in, I guess, in England, since we know that most of the plant roots are in the top foot of soil, they will take out the top foot, pot over here, dig down another foot, pot over here, and then reverse and go back in, so the soil near the surface doesn't have your roots in it. I had one person do that. He says it worked. I ain't never doing that again. Because that's a lot of work. But if your soil is real soft and you got cheap labor, then that's another possibility. You rotate the soil that way.
25 avocado. Can you do that? No.
Yeah, so my father's was a bonsai artist, and their goal was to keep the same plant in the same pot forever. So it was a minimum of every 10 years they would pull the plant out of the pot, knock off half the dirt, trim the roots a bit, trim the top so there's no shock. You got to balance the root in the top. Put the same plant back in the same pot with fresh soil. Every 10 years they replace half the dirt. In the old days, like in Europe, they would construct these big boxes. There are plans on the internet to show they made these wood boxes with removable sides. So every year you can remove one side of this of the root system in the dirt and replace it with fresh dirt, and then put it back. Next year, move a different side, place that dirt. So you can do that on trees and keep them going in the same pot forever. There are plastic tree box they make that are bolted together that you can do that with. But you can make your own box up too that you can have removable sides so you can replace the soil. But yeah, you can rotate the soil just by replacing it.
But
Keep
every
plants.
year you can't just like dig it out and put it in the soil.
Yeah, if you do a good enough job, you can. Yeah, you can take half you can disturb half the roots of a plant without really messing it up too much. So you could dig in from the top, take a whole portion of that plant root system out in the dirt with it and replace it. It's easier if you can pull out the side and then work from underneath because there's a lot of roots on top that get in the way. But yeah, that's another option. I mean, one way to renew, one way arborists would renew trees. So if they have a tree that's real, well, actually from the top, here's the trunk here. If the tree was going downhill, what they would do is they would either dig holes near it and put new dirt in there, or they would make trenches radially outward so they wouldn't cut through too many roots and fill them with sand. They'll give the tree a new root system closer to the tree, new place to grow roots, and that tree would invigorate the tree. Because some trees don't live very long because they don't have enough roots area to grow in. Like you say, the smaller trees like um, red buds or birch trees or flowering pears, things like that. They don't live very long. 20, 30 years is usually about it. But if you do this to them, you can get them, keep them going along. They call it vertical mulching, but it's actually just replacing the soil close to the tree.
So the solution would be availability of new soil or getting rid of the bad things in the old soil.
Both. The dead roots have the bad things in them. If the dead roots weren't there, there wouldn't be any bad things. Most of the bad things exist on the dead stuff. They don't exist in the soil. It's the dead stuff.
In that example, there's a bunch of bad stuff still there.
But you give them a clean root run.
So they can get some roots in good soil and the other roots are gonna suffer and
Right.
get rid of that.
Right.
It's like a shot in the arm. Just to
What if we use
Oh, the
more
weeds.
soil to plant it?
Yeah, it's fine.
Yeah.
Our soil is a soil substitute, but sand would be the closest thing to real dirt you can buy. In bags, that is. You can buy real dirt in truckloads. I mean, in rose gardens, what they've done, some of the bigger rose gardens, so you invigorate the rose, they would just trench along the front and put new soil in.
No, but
Because roses get ugly in 10
the
years.
years that we plant in the, you have to do that every year. You get new soil.
If you want to keep the plant looking as fresh as possible, yes, but most plants don't need to replace the soil every year. Most plants go 10 years. I mean, the smallest plants, like shrubs, like in my old neighborhood, we had ground cover on the hills. The first when I moved there was rosemary ground cover. 10 years later, most of it was dead, so they pulled it all out, put in Mycorrhizal. That lasted about 10 years too, and then they replaced that with lantana. So they had to keep changing the ground cover they're using because ground cover doesn't have a very big root system compared. The trees are the same trees on the slope. California peppers, they can live probably 40, 50 years before they get old. But the ground cover, about 10 years was about it. So
I just want a lantana looking good. I have a lantana in the section, and there's one that's next to a big yard, and then this one is surrounded by cement, and this one's ugly, and this one's beautiful. It's just hard because there's not enough space for the roots, and
Right.
it's a 10-year cycle. Okay. Just answer the big mystery.
any other questions? Yes.
If you're going to try and grow your tomatoes in a pot, how big of a pot do you need? And
Depends how big you let your tomato grow. So if you, a friend of mine used to grow, he was a commercial farmer for a while, and then he started doing nursery stuff. He would grow 400 tomatoes a year, each in a 15-gallon container. 15 gallons, not really 15. 15-gallon container is probably around 12, 12 actual gallons. And he would just grow one stem straight up. He says if you let this thing branch, it's too much foliage for that container. So he would do that. He just pruned all the side branches off, just with one stem. Because that's what he was used to in commercial farming, like in hothouse farming. This is off the subject. Go ahead, turn this off.